Hello all, welcome to part 31 of the Wireless LAN Security Mega Primer. So in this video, we will look at how to crack EAP MD5 using EAP MD5 Pass and another interesting tool. So we've seen EAP MD5 setup in the last video, and I guess most of us have already figured out there are a couple of issues if you run the experiment. Now to begin with, EAP MD5 typically cannot be used for wireless simply because it does not support any sort of key generation or exchange post authentication. At the very same time, it does not support any mutual authentication. The onus is on the client to go ahead and prove its identity to the Radius server and not vice versa. Now, as you can imagine, this is basically an open playground for man in the middle attacks and any other impersonation attacks where an attacker can impersonate the Radius server. At the very same time, as you've seen, both the plain text challenge as well as the encrypted response, the hashed response, are over the air totally unencrypted. This is a problem because an attacker can go ahead and sniff both the challenge as well as the response and then go ahead and pass it through various dictionary or educated brute force attacks. So what is the mathemagic behind MD5 cracking? Well, very simply, the hash is nothing but an MD5 of the EAP response ID, which is a little number in your EAP packet, along with the shared password known both by the Radius server and the user. This is actually the password which we entered in the Radius server's users file, which, if you remember, was username security tube and password demo12345. Finally, this is concatenated along with the Radius challenge, which is the long 16-byte challenge which the Radius server sends. Right? So if you look at this equation, what are things which are available to the attacker by sniffing the air? To begin with, he knows the hash because this is the response of the client sent to the Radius server. He knows the response ID as well because he can sniff it off the packet, which is plain text. And finally, he can also know the challenge which was initially sent by the Radius server. So if you plug things in, well, he has the hash, he has the response ID, he has the challenge. So what he's going to do is, if he can try various combination of passwords to check that after creating the MD5 hash for a given password, along with the sniffed response ID and the Radius challenge, if he gets the hash which the client sent in response, then he knows that his guess for the password was correct. And this is exactly how the cracking process works. So let's go ahead and do a demonstration. Now the setup is identical to what we had in the previous video. If you're confused, go back, have a look at that setup. I'm going into my backtrack machine, and what I'm going to do is start my Radius server with the exact same configurations as previously. So the Radius server is all up and running. Let me check if I have my network interfaces up as well. So I guess one of the first things which I need to do is bring up the WLAN 0 interface, which seems to be down for the time being. Let me see if the device has been attached. So let's go ahead, attach the wireless device to it. And now we should have the WLAN 0 interface up, with which we are going to sniff the packets. Right, let's create a monitor mode interface. And what we are going to do is, let's launch Wireshark so that we can sniff on this monitor mode interface. Now before that, we need to figure out on which channel the security tube access point is. So let's quickly run arrow dump and we can see that it is on channel 1. So let's set the card onto channel 1, right? And now what we are going to do is, let's start Wireshark. Start sniffing on Monzero interface, a lot of traffic. What we are interested in is just EAP packets, right? And now let's go ahead and connect the client to generate some EPOL packets. Blah blah blah. So let's go here, let's go ahead, connect to our client to the WP Enterprise EAP MD5 network. We enter security tube and we enter the password demo12345, right? And now we go back here to our attack machine, and if you notice, we have captured all the packets, right? There seems to be a retransmission packet as well, but no worries. Let's stop the capture here and let's save all of these packets into a separate file. So let's hit save as, and we'll save it in this directory, and we'll go ahead and call it EAP MD5 cracking. Sometimes I've seen it's a good idea to actually create these directories and store capture files. Especially if you're training, then many a times, you may use some of these offline captures instead of having to conduct the experiment every single time. So we've saved all the packets. Now let's go to that directory. And here is our packet, right? Perfect. So now what we are going to do is we're going to start the cracking process. So there are basically two tools which we are going to use for this entire demonstration. The first is something called EAP MD5 Pass, which has been written by Josh Wright. Now you can give various options to this tool. You could go ahead and mention the challenge response directly as input to the tool. So let's go ahead and try that, because that will give us some firm understanding about how this would work. Right, and along with that we're going to run another tool as well. Actually, let's run that tool first, because that would take a little bit of more time, simply because I want to show you the entire cracking process. So here is another tool which is not included, I think, with the Backtrack distribution. So I have downloaded it online, and that tool is called EAP MD5 Crack. Now this is a wonderful tool which I discovered through Twitter yesterday, and I think it was hosted, and this tool was actually demonstrated in the Paul.com show, and the authors pointed me to it. So this is the tool. Let's go full screen on this one. And actually what we could do is we could just go back to the original directory. We just run the tool from the remote location. So basically it's in pentest, wireless, new tools, APMD5, and let's look at the different options the tool requires. So the options are pretty simple. If you want to do a dictionary attack, we need to go ahead and give it the PCAP file, we need to give it the dictionary, verbose if we want to see a bunch of traces, right? So what I've done is I've already copied the default dictionary file, which is the darkcode.list file, in Backtrack here. Now demo12345 is not a password which is there in this file, so I've just concatenated it in the end, so that is the last password the tool is going to try, right? So let's go ahead and run the tool with all the requisite options. The first is the PCAP file, I think, which was EAPMD5 cracking, and then you actually have the dictionary file, which is the dark code file which is here. Then we can hit it with verbose mode, and the first thing it does intelligently is discovers that there is an EAP MD5 exchange. This seems to be the challenge, and this seems to be the needed response, right? So it asks whether we should go ahead and continue with this specific packet. So let's hit yes, and then it is going to start attempting various passwords based on the equation we looked at on the slides. So while this is going on, let's go back to, I think we'll have to open up a new terminal. And in this, we are going to go ahead and demo the EAP MD5 pass tool. Now, even this can take an input as a PCAP file, but what we'll try and do is something a little bit more interesting, which is go ahead and give all the inputs directly based on the trace file. So let's look at the trace file. Now, the first thing we require is the user's identity, which, if you may remember, is going to be there in the first packet sent by the client, which is security tube. This is the username, right? So the username turns out to be security tube, and then the second input which you're going to require is actually the EAP MD5 challenge value with the -c option. Let's go back here onto Wireshark, and if you look at it, these are the two packets. I guess the second one is a retransmission. You can actually see the retry bit, and what we require is this value. So let's go ahead, copy this value, go back here, paste it, and let's just go ahead and create the logical boundaries on a per byte basis. So the beauty is with this tool is that you could probably give it an input from various different tools and places, and then we require the response. So this is the response. Let's copy the response as well, and for the response we are going to use ahead the -r option. So let's paste that as well, and let's go ahead and ensure everything is okay. Right, perfect. And what we're going to do is we're going to go ahead and feed this a different dictionary file, which actually already contains the passphrase, right? One of the other important things you would require is an EAP ID value, and this is something I'll tell you how to fetch from the packet. This is the EAP response ID value, and basically this is going to be there in these packets if you kind of go through them, right? And if you see, here is what you require. The value is 102. Go back here, give 102. If you want, you could increase the verbosity, and then you need to feed it a dictionary file, which I'm going to feed it a file called okay, there's no file here. I'm going to go into the Wi-Fi directory, and then I have two options. I think one of these has the correct passphrase. So let's use dict1 first and see what happens. And if you notice, it says it was not able to get the password. If I use dict2, if you notice, dict2, it says the dictionary attack worked and the password is demo12345. So very quickly, if I were to look at each of these files, which is dict1 just contains ABCDEFGH, and dict2 contains two values, the first of which is the actual passphrase. So this is how, by specifying the challenge as well as the response, we are able to crack the MD5 hash and get the original passphrase. Now, I think this is still going on here, and in some time you should be able to see the exact passphrase. So the conclusion of the story is that EAP MD5 is very, very bad if you're using it over wireless. And the answer to that is very simple. Because you have the MD5 challenge as well as the response, both of them clear text in the air, which means by using the challenge and the response along with the response ID, it is very simple to try and figure out what the password could have been by using either a dictionary attack or an educated brute force attack. Now, when I say educated brute force, the whole idea is to limit the number of possibilities, limit the length of the password, and things like that based on what you feel a actual human would do. So, I guess, it's almost end of the video. I'm just waiting for the password to get cracked so that we know what is the real password. Please try this entire demonstration all by yourself. Forthcoming videos will involve other EAP types which are going to be more complicated, right from the setup to the entire attack taking place. So it may be a good idea to begin from the basics. So while the cracking is happening, once again, thank you for all the donations, all the feedback. I really request you to go ahead and carry on that and to contribute newer videos to Security Tube. And with the current donations coming in, I'm able to free up more time to really sit down and make more interesting videos for the entire community. And I've already seen more people start off with mega primers. Andrew is doing a great one. I remember Patrick and Rene doing another one as well. And recently, you've also had Jester go ahead and create a mega primer for cryptography, which is just started. So this brings us to the end. The password is cracked. So this is another great tool which I would recommend, EAP MD5 crack, along with, of course, our very own Josh Wright's EAP MD5 pass. So that's all for this video. Hope you enjoyed it and see you in the next one. Thank you.